instruments we have discussed, and some of the gate questions also we have discussed. Yeah. Chalo. Is audio video is very clear? Please confirm me, audio video sab kuch clear? Okay. Chalo. So in the syllabus, what actually I'm going to be covered? And AC. Okay. So DC bridges and AC bridges. So first we'll start with the DC bridge. In the DC bridge, we are going to have the Wheatstone bridge. Net issue. Net off cheyi mobile. Mobile net పెట్టుకొని మాట్లాడుతున్నావా? Yes, I think the issue is chalo. Sorry here, sorry for the disturbance. So that was a issue in the router. Now I am continuing. Chalo, we are having the bridges, two types of bridges, DC bridges and AC bridges. In the DC bridge, we are having in the syllabus, we are having the Wheatstone bridge. Next, we are having the Maxwell bridge, Kelvin's bridge, Kelvin's double bridge. So these are the DC bridges. When it comes to the AC bridge, Maxwell inductance bridge. Next, Maxwell inductance capacitance bridge. Maxwell inductance capacitance bridge. Next, case bridge. Anderson bridge. Owens. Next, sharing bridge. 𝐂𝐸 bridge, Wien's bridge, okay. So these all are the bridges, okay. Thank you, Sujal Patel sir. Yeah, I think now it's fine. Now everything is going good. Chalo, we'll discuss first Wheatstone bridge. First Wheatstone bridge से start करेंगे. We'll start with the Wheatstone bridge first. So on Wheatstone bridge there are very possibilities of questions are expected, okay. So number of questions are expected in Wheatstone bridge. Every year we are getting one question in the Wheatstone bridge. I think all of you are familiar with the Wheatstone bridge, which contains the 4 resistors, okay. So if you see the Wheatstone bridge basic diagram, this is R1, this is R2, this is R3, this is R4, so I can take this as a supply voltage Vs. So this is R1, this is R2, R3 and R4, and here comes our galvanometer. So this is our galvanometer. So let us take this meter resistance is infinite. So now if I am taking the branches, so these are the branches. So this I is split into 2 parts. So the current passing here will be 0 and the current passing I1 and I2. Okay, so this is the V bridge. So whoever are watching there, just confirm me. I think from my side it is fine. So from your side it is going to be clear or not. Yeah. So V bridge we have to discuss now. So first of all, if all the resistors are equal, I am taking the meter resistance as infinite. The galvanometer is having infinite resistance. So I have taken the meter resistance as infinite, so that there is no current is possible here going into the galvanometer. So now if I am taking bridge balance condition, suppose bridge balance condition, if you see the bridge balance condition, so what was the bridge balance condition? Let us see here. So V bridge is equal to balance means VAB must be equal to, or VB minus VD must be equal to 0. The potential difference between these two terminals must be equal to 0. So if I am seeing this, the VB can be written as I1 R2 plus VC. Some networks theory knowledge should be there to solve these questions. Okay, so VB is equal to I1 R2 plus VC and VD is equal to I2 R4 plus VC. So V bridge I can take it as VB minus VD, which is equal to 0 at balance. So I can write as I1 R2 plus VC is equal to I2 R4 plus VC. So now what happens, this VC gets cancelled. So what is I1? I can write it as I1 as Vs by R1 plus R2 into R2 divided by Vs by R3 plus R4 into R4, because I1 is a series current passing through this resistor, I2 is a series current passing through these resistors. So now Vs gets cancelled. So if you see this particular balance equation, we see the balance equation, we can establish a balance condition. What is a balance condition? You can check there. What is a balance condition? So what is a balance condition? You can check there. So what is a bridge balance condition? If you see this, so what I can write it as R2 by R1 plus R2 is equal to R4 by R3 plus R4, R4 by R3 plus. So if you take the cross multiplication, of these R2 R3 plus R2 R4 is equal to R1 R4 plus R2 R4. So this R2 R4 gets cancelled. So R1 R4 is equal to R2 R3. So this is the bridge balance condition for Wheatstone bridge. The product of opposite arms must be equal. So this is a bridge balance condition. Yes, Rafsan, how are you? Very good. So this is the bridge balance condition. So if the bridge is balance condition, that is a scenario. Very good, Rafsan. So but this condition is possible if and only if the meter resistance is infinite. Okay. So this is a bridge balance condition. Suppose if you want to know unknown resistance R4, suppose if R4 is the unknown resistor, I can write R4 is equal to R2 R3 by R1. I can write it. R4 is equal to R2 R3 by R1. Like that I can write. Okay. Now if I am going for another level of operation. So what is another level of operation? Suppose bridge is not balanced. If bridge is unbalanced, okay, the bridge is unbalanced. Students, the bridge is unbalanced. So what I can write here, the V bridge, VB minus VD cannot be 0. So I can write like this, V bridge is equal to VB minus VD not equal to 0. So what is a VB minus VD? I can write it as VB minus VD, what I can write it as VB is equal to I1 R2 plus VC, I1 R2 plus VC minus I2 R4 plus VC, I2 R4 plus. So now I can write this as I1 R2 plus VC minus I2 R4 minus VC. So VC gets cancelled. So what I am going to get? I am going to get as I1 R2 minus I2 R4. So what is I1? that is Vs by R1 plus R2 minus this is Vs by R3 plus R4 R4. So V bridge can be written as Vs into R2 by R1 plus R2 minus R4 by R3 plus. So this is the Wheatstone bridge expression. Please note down. So these are all important derivations with respect to Wheatstone bridge. Okay, so this is the V bridge expression. I hope all of you got it. Okay. Anybody is having any doubts, you can give here. So now if I am going for this V bridge, so what I can write here, V bridge. This V bridge can be written as Vs into R2 by R1 plus R2, R2 by R1 plus R2 minus R4 by R3 plus R4. Suppose if R1 is equal to R2 is equal to R3 is equal to R4 is equal to R, then what happens? Thank you, Rafsan. Where are you from? This V bridge will become equal to 0. Suppose if any one of these resistors is changing, for example, if you see this particular bridge, suppose let us take R4 is changing its resistance. So this is our R1, R2, and this is our R3, this is our R4. So this plus minus, this is Vs. Okay. So now if you check, if R1 is equal to R2 is equal to R3 is equal to R4, initially all are same. This is R, this is R, this is R, this is R initially. Thank you Rafsan. You are from Tripoli. So now if one of the resistance is changing by delta R, if R4 is changing as delta R, then what happens to V bridge? Suppose if this is a variable resistor, V bridge is equal to Vs into R by R plus R minus R4 is changing as R plus delta R. This is R plus delta R. So I am going to get this here as 1 by 2 minus 2R plus delta R plus delta. Okay, so if you check the simplification of this, this is 4R plus 2 delta R is 2R plus delta R minus 2R minus 2 delta R minus 2 delta R. So now if you check, 2R gets cancelled, 4R is very much greater than actually here. So the V bridge will be equal to Vs into delta R by 4R, approximately the mod of the V bridge. This is one of the important expression, my dear. taking the 4r is very much greater than 2 delta r. So please note down. Noted down. All of you noted? Okay. Chalo. So this expression I can use for numerical problems. Similarly, if I am taking another Wheatstone bridge like this, the different possibilities of Wheatstone bridge cases. So if I am taking this as r plus delta r, and if I am taking this as r minus delta r, and this is r, this is r. So what is going to be the bridge expression in this case? Can anybody tell me? What is going to be the bridge expression here? So what can be the bridge expression if the meter resistance is finite? Thank you, Rafsan. Can anybody tell me what is going to happen in this scenario? So let us take the same expression of free bridge, which is R2 by R1 plus R2. What is the fundamental expression? That fundamental expression let us take here. So V bridge is equal to Vs into, what is that expression? R2 by R1 plus R2 minus R4 by R3 plus R4. R4 by R3 plus. So now if I am taking this as our R1 as per our bridge expression, R1, R2, R3, R4. So these are our bridge expressions. This is R1, this is R2, R3, this is R4. So now if I am taking this, R2 is R minus delta R, R1 is R plus delta R, R2 is R minus delta R, and R4 is R, R4 is R, R3 plus R4 is. So delta R gets cancelled. So here I can take it as Vs into R minus delta R divided by 2R minus 1 by. So Vs 4R, 2R minus 2 delta R minus 2R. So 2R gets cancelled. So now if I am taking the V bridge magnitude, that will be equal to Vs to delta R by 2R. So this is our V bridge expression. So what we call this as half bridge. So have you seen when two resistors are changing, when one resistor is changing, what is the scenario happening here? So then one resistor is happening, so we can call this as quarter bridge. One out of the four is changing, so that's why we call it as quarter bridge. Okay, wow. Similarly here, two resistors are changing, that's why it is called as half bridge. Okay, anybody is having any doubts, let me know. If anybody is facing any doubts, let me know. Any doubts here till now? Chalo. I hope all of you got this clarity now. Now if I am going for full bridge, full bridge means what is the possibility? Suppose the four arms of the bridge are changing such a way bridge is unbalanced. Four arms of the bridge is changing such a way the bridge is unbalanced. This is R1, this is R2, this is R3, this is R4. All if you are there, try to understand what I am doing here. This is R1, this is R2, this is R3, this is R4, and this is the Vs. And here I am taking so this is the meter resistance infinite. Suppose if I am taking this as R plus delta R and this also R plus delta R, this has R minus delta R, this has R minus delta R. If you check now, this is R plus delta R, this is R plus delta R, this is R minus delta R, this is R minus. Okay. So I have connected the bridge such a way, the resistors are properly placed in such a way the bridge should not become unbalanced. It should not become balanced. Suppose if I keep R minus delta R here and if I keep R minus delta R, R plus delta R here, then product of opposite arms will be balanced. It should not be like so. This is a perfect configuration. Four the resistors are changing in a Wheatstone bridge. Then what happens? The Wheatstone bridge balance voltage. So bridge is unbalanced again. So V bridge expression was Vs into R2 by R1 plus R2 minus R4 by R3 plus R4. So now if I am taking this R2, what I can write R2? R2 is R minus delta R, R1 is R plus delta R, R2 is R minus delta R, R4 is R plus delta R, R3 is R minus delta R, R4 is R plus delta R. Okay. Anybody is facing any doubts? You can ask me. Rafsan, where are you from? Very good. So now if I am simplifying this, delta R gets cancelled, delta R gets cancelled. So here this is Vs into R minus delta R the whole divided by 2R minus R plus delta R the whole divided by 2R. So now if I am taking this Vs 2R like this, so this will be R minus delta R minus R minus delta R. So R gets cancelled. So this is Vs into minus 2 delta R by 2R. So 2 gets cancelled. So the V bridge will be equal to Vs into delta R by R. Vs into delta R by. So this is what we call as full bridge. What we call this as full bridge. So water bridge, half bridge, full bridge. A beautiful theoretical explanation I have given. These are the different configuration of the Wheatstone bridge: water bridge, half bridge, and full bridge. So let me write the equation now. Water bridge, V bridge is equal to Vs by 4 into delta R by R, and half bridge, V bridge is equal to Vs by 2 into delta R by R. Full bridge, that is Vs into delta R by R. And all these formulas are valid if and only if conditions satisfied. The meter resistance must be infinite and all initial resistors must be same. So when this matches, then only all clear? Sir, can I just use V bridge generalized formula to define voltage if any resistance change except using quarter? Yes, yes, the generalized formula is that only. These all are derived from the generalized formula only, Rafsan. R2 by R1 plus R2 minus R4 by R3 plus R. This is a generalized formula which is nothing but the voltage division rule, na? This is nothing but the voltage divider rule. Yes. From the generalized formula only these all are derived. From the generalized formula only all are these derived. Can you solve this question? Can you solve this question? IIT कानपुर 2015 का सवाल है. This is IIT कानपुर 2015 का सवाल है. An unbalanced DC Wheatstone bridge is shown in the figure. At what value of P will be the magnitude of V0 maximum? So how to solve this question? At what value of the P is asking? At what value of the P it is going to? So if you see the Wheatstone bridge here, try to answer this question. One question. Afsan, can you do it? Try to answer this question. Unbalanced DC Wheatstone bridge shown is in the figure. At what value of P will the magnitude of V0 will be maximum? So at what value of P is asking, that means dV0 by dP must be equal to 0. So dV0 means these two resistors are in series, so we have to apply the voltage division rule between these two resistors now. Okay. Make it fast here. So how to do this? So how to do this? dV0 by dP. First of all, V0 we have to find out. Solution I am writing here. So what is a V0? So the V0 can be taken as, so VA minus VB. First of all, V0 I can write it as VA minus, so VA I can take it as E into, this is E into PR by, this is P into R divided by PR plus R into 1 plus X minus, this is PR by PR plus R. So because I have taken the voltage division rule with respect to this two, because plus is here, so I can take anyway. Answer A. Sure. Okay, very good. Have you done it? Nice. So if I am taking this as E, this is PR, PR plus R plus XR, PR by PR plus R. Any mistake we are doing? if you take R out, it will be P by P plus 1 plus X. Here if you take R out, P by P plus 1. So dV naught by dP we have to do. So that means P plus 1 plus X whole square, P plus 1 plus X into 1 minus P 1 plus 0 minus P plus 1 whole square, P plus 1 derivative of this 1 minus P derivative of this is 1. So this is equal to 0. So if you simplify, then the P will be coming as root over 1 plus. Simplify this dV naught by dP. So maximum will be dV naught by 0. So option A is the right answer. Option A will be the right answer. Got it? I hope all of you understood. So now let us go for, thank you, AC bridges introduction. If you see the AC bridges, in AC bridges I will tell you the trick. I am not writing the bridges names here, but I will tell you the tricks, how to remember the tricks of the AC bridges. So first I am taking, in AC bridges, in a Wheatstone bridge, the basic purpose of Wheatstone bridge is, the basic purpose of Wheatstone bridge here is to measure only resistance, majorly resistance. But if you take AC bridges now, we can measure resistance, we can measure inductance, we can measure capacitance, we can measure the frequency, okay, we can measure the impedance. So these are all the applications of AC bridges. In AC bridges, mostly we are going to get the theoretical questions. So if you see the AC bridge, what are the theoretical questions we are going to get? So first comes the Maxwell inductance bridge. Maxwell inductance bridge. So the feature of this Maxwell inductance bridge here is, it is suitable for self-inductance measurement of a coil. So Maxwell inductance bridge is suitable for inductance measurement of a coil. But the condition is, will tell you, second also same, Maxwell inductance capacitance bridge. Maxwell's inductance capacitance bridge. Capacitance bridge. It is also suitable for inductance measurement. It is also suitable for inductance measurement. So, but the point here is the Q factor must be more than 1, less than 10. So it is suitable for medium Q factors values only. Suitable for medium Q factors. It is suitable for the self-inductance measurement of the coil whose Q factor is medium. Okay, na? It is suitable for the self-inductance of a coil whose Q factor is it clear, Rafsan? Next, the third comes Hayes bridge. So if you see the Hayes bridge, this Hayes bridge is also for inductance measurement, self-inductance measurement, but the condition here is Q factor must be greater than 10. Q factor must be greater than, are you following? Q factor must be greater than. The next one comes as Owen's bridge. Owen's bridge. If you see the Owen's bridge, in the Owen's bridge, it is suitable for self-inductance measurement of incremental or decremental. It is also Q factor less than 1. Next comes the Anderson bridge. Anderson bridge is also for self-inductance measurement whose Q factor is less than 1, and it is always gives you the accurate measurements. So these all are for self-inductance measurements. Next comes the capacitance bridges of sun. Sharing bridge. Before that we will get Desauty bridge. Desauty bridge. If you see the Desauty bridge is for dissipation. It is capacitance measurement is also suitable for dissipation factor. For coils, will be having the Q factor. For capacitors, will be having the dissipation factor. Next, seventh one, sharing bridge. Sharing bridge is also for capacitance measurement. It is also suitable for epsilon R measurement, relative permittivity of the medium. M for medium Q factor, H for high Q factor, O1 to O1 for incremental and decremental, sun for under 1. All of these your tricks never forgotten. Very good. So this epsilon R, this is for dissipation factor also. Very good, Rafsan. Do you have any rank? Very good. Next, 8 for Wien's bridge. Wien's bridge is for what application? Wien's W stands for the frequency, because omega means 2 pi f. You can remember like this. I am telling the techniques now here. In Wien's bridge we are having W stands for 2 pi f, F stands for frequency. Sharing में such है, so such it gives you the true, that means it gives you the true dissipation factor measurement, no dilemma. In Desauty we are having D for doubtful, not accurate. So these are the ways you can remember doubtful dissipation factor, double capacitors are present. Excellent, Rafsan. Superb. Next, Anderson में sun है, so it is always less than 1. Son is always less than father, if you take father as 1. Next, Anderson में A है, so A stands for accuracy, accurate measurement. Next, ovens. In microwave oven will be incremental and decremental. In Hayes, H is there, so this is for higher Q factor. Next, Maxwell, M is there, so medium Q factor. Beauty. Excellent, Rafsan. I hope everything is clear. Okay. So now I am giving a question as assignment. Okay. I am giving a question as assignment. Try to do this question on DC Wheatstone bridge. There is a galvanometer, but this time the meter is having some resistance. This is 400 ohms. This is 400 ohms. This is 400 ohms. This is 400 ohms. The meter resistance is 1 kilo ohm. Meter resistance is 1 kilo ohm. So this is a supply voltage. Supply voltage is suppose 12 volts. The deflection sensitivity of galvanometer is given as 0.2 degree per 1 microampere, and the meter resistance of the meter is equal to 1000 ohms. And if this is a variable resistor, R4 is 400 ohms, the delta R is plus 1% of R. 5 minutes. 1% of R. Then calculate deflection in degrees. Okay, so try to do this question as a task. Let us do this question as a task. So try to do this question. Enough for today. In tomorrow's class, you tell me the answer.